next up from Spain, we have Gustavo Espellata, the Fry Operations Manager from AVRAMAR Company. Could you please start your presentation?
Thank you, Simon. Thank you, Patrick. We can go on. I mean, we are going to talk about the use of Artemia in this case in hatchery that we are producer of sea bream, sea bass, and meager. Here you have a clear example of how it is the feeding strategy for the different species. As you see, we are using also other vector for the feeding, that is rotifers. And we are introducing two types of Artemia in the case of the bream and meager, that is AF and AG. And in the case of bass, we are also only using AG. And the weaning, the weaning process, that is when we take out the Artemia feeding, it is depending of the manual, but more or less it's around 40 days post-hatch until 55 days post-hatch. Next slide. As I was commenting previously, the sea bass normally producer without rotifers, only with EG. And here you have the images of the three different species, the three different larvae, how it is the control of live prey under the stereoscope. I mean, because one of the important things that we have to control it is how it is the intake, the Artemia intake in the larvae. So we are controlling every day that the larvae is taking the Artemia. We are controlling the leftovers in the tanks, of course, and we are pushing the larvae to go to the early weaning. Okay. Next slide. So what are the pros and the cons of Artemia, of using of Artemia in the Mediterranean aquaculture, at least for us? No, the pros, it is what we were talking during all this session, that we have consistent results in survival and deformities is the main vector that we are using for a long time. So this is totally clear. We have a good supply chain, so we don't have risk of that. And technically, now it's easy to handle. From the other side, we have, in the other hand, we have that the biosecurity is what we have. And Patrick have talked at the beginning of the presentation about the Vibrios, the cost also. We have the Artemia that has a higher price, the labor, and the more complex installation that finally give us maintenance cost. And also you have a risk that is possible, even if that is strange, that you can lose one tank or you have mortality in the Artemia and you lose some feeding in the larvae, and this can be a risky situation for your production. So the question is, can we produce with Artemia, without Artemia? And if you are telling me from the experimental point of view, at least in these three marine species, I will tell you that yes. If you are if you are asking me about the industrial point of view, I will tell you no. Industrial point of view is not an experimental plant, and we want results, we want budgeted, and we want something that we have to produce the fish that we need for the production. So it's not going to be possible. So it's what I said here, that all the cons, the pressure is to reduce the Artemia consumption and to go to early weaning strategies, but it's not very possible to have good results in survival and deformities to go that. Yes, there are extreme manuals with low Artemia consumption, but with unstable results. So that's is limiting. And basically that is done because the efficiency stomach of the species are involved in all those processes. So the image you can see here in the image where it is the open mouth, the open anus, and the efficient stomach according to one study. So next slide. So in our daily routines, how we use the Artemia in the case of our hatcheries is more or less what we were talking about, and also what Dimitris explained in the previous presentation. We are every day we are counting the tanks. We are using in our case 3 cubic meter tanks. We are keeping 30 degrees for the hatching. It's 20 hours hatching. We are keeping one important thing that it is that we have the prevision that we have to go and we have to consume. And we are doing also a control of enrichment daily under the stereoscope and monthly by the laboratory in order to check that everything goes well. And after that, we are transferring, after the harvest, we are transferring the Artemia to the cold storage in 4 degrees. And after that, we go to the larvae also by a pneumatic pump. And about the KPIs in our species, we are more or less to give you an idea. Sheep bream, it's around 50 kilos per million produced, so we are very far away from the stream. Also, sea bass is around that. And meager, we are in 100. Meager, it's a fast grower species which needs very high, let me say, doses of Artemia, of high concentration of Artemia. So thank you very much.
Thank you, Gustavo. Next up from Ecuador, we have Stanislaus Sonnenholzer from CNAME. Please go ahead.
Hello, good morning, everyone. I would like to first thank the organizers for inviting me to this webinar on the use of Artemia cysts around the world to share some of the information on the practices that are carried out in the shrimp hatcheries of Ecuador. Next slide. I would like to start this presentation by highlighting the importance of shrimp production for Ecuador's economy. The shrimp farming is one of the main non-oil primary products that generates foreign exchange for Ecuador, together with bananas, well above products such as cocoa, coffee, and fisheries. Although there are other aquaculture species that are grown or produced in Ecuador, such as cobia and tilapia and other fishes from the Amazon, the production is marginal compared to the shrimp production. And most of the Artemia cysts are used to feed the shrimp larvae. Artemia cysts are mainly imported from either the Great Salt Lake in the United States and from several lakes of the Russian Federation. The importation of Artemia cysts has increased significantly in the recent years, with about 200,000 kilograms being imported during the 2020. Regarding the market share, about 60% comes from the Russian Federation and about 40% comes from the United States. The Undersecretary of Aquaculture of Ecuador has registered about 386 shrimp hatcheries. Of them, about 200 have legal agreement, while the rest are in process of obtaining authorization, or the rest are about 100 or so are illegal. It's estimated about the production of about 80 billion post-larvae to seed about 218,000 shrimp production hectares. Next slide, please. In the following slides, I'm just going to briefly present you some of the most common practices in shrimp hatcheries of Ecuador for decapsulation, incubation, harvest, disinfection, and storage of Artemia cysts. Next slide, please. With regard to incubation, I have to say that about most of the Artemia cysts are decapsulated. We estimate about 98 of the hatcheries use decapsulated cysts for feeding their shrimp larvae, and maybe less than 2% use direct incubation. Next slide, please. For the decapsulation, they use usually commercial available chemicals, commercial bleach, no? and sodium peroxide, 50% about active ingredient. To handle those chemicals, they usually, the workers, they don't use or handle the chemicals with any protection, usually either mask or gloves. So it's very rare to see them handling these chemicals in the hatcheries. During the process, they usually don't measure the chlorine activity, and the way they monitor the decapsulation, usually they don't do it. They just see a change in color from the brownish to reddish, and that's the way they stop when they start to washing out the different cysts, the cyst. They usually, they don't, after that, they don't neutralize the chlorine, and the effluents that are during the washing are directly washed out into the drainage. You can see doing this process either indoor or outdoor. You can see a couple of pictures over there where they do the hydration, and then they use the. I have two. Yes, next slide, please. Two videos. You can play them. Where you can see where they use. They have to prepare all these tanks, and then they have the solutions, the chemicals, and they apply it to the hydrated cyst, and then they start doing the washing in this type of system. No? And as you can see, they just wash out everything on the floor. With regard to the incubation, we have different types of tanks. They do it in different types of tanks. They can be rectangular concrete or fiberglass tanks. Usually the volume is about between 500 liters to 1 ton tanks, mostly conical. So you can see in this picture the different settings that we can find in our hatcheries. Next slide, please. Usually, with regard to the temperature, with regard to the conditions or parameters during the incubation, they usually don't heat the water. They use temperature, ambient temperature. So the temperature may change according to the season between 23 to 33 degrees centigrade. Usually the salinity is full strength seawater, what they collect from the sea. They use illumination, usually those LED lights that have more than 2,000 lux. The pH of the seawater is between 7.5 to 8.1 pH. They usually don't use any type of sodium, bicarbonate to raise the pH. They use usually oxygen. No? They don't monitor the oxygen, just full mixing with the air stones. They usually use cyst density of 1 gram per liter instead of 2 grams per liter, which is usually recommended by most of the textbooks. And as I mentioned, the tanks can be cylindrical, but either with conical bottom or flat bottom. No? And incubation is usually performed between 24 to 36 hours. Next slide, please. For the separation after incubation, to separate the nauplia from the debris, they use either or mostly hydrogen peroxide, 50% active ingredient, to separate the embryo membranes and other floating debris. So when they use hydrogen peroxide, these debris float, and nauplia it's on the bottom. and then they just remove it from the surface after stopping the aeration. And when they use some use also brine solution, and the process is inverted, so the nuclei floats and the debris sinks. And that can be only, and then they remove it by opening the valve and removing the bottom debris. Next slide, please. During the harvesting, usually nuclei are directly collected from the hatching 200 screen mesh, usually on the floor. They don't use any water bed. And sometimes they use, I would say mostly they disinfect it either with formol or hydrogen peroxide at 50%. And there's a small video that can, how it's performed of one of those hatcheries. So it's directly collected from the hatching tanks into these meshes. Next slide, please. And yes, as I saw also in other countries, they also mostly they kill or inactivate the nuclei after harvesting. They do it both. Some put it in these plastic bags after waiting. Usually they are 1 kilo bags, and they either put it in the freezer for its further use, and some kill the nuclei or inactivate it by dipping them into hot water or boiling water. So there is also to end a small video of, you can see how it's done. They have these pots, boil the water, and then they put the Artemia bags. They leave it there for 5 to 10 minutes. There's no control. They just assume that they're dead after that dipping, and then they freeze it and for further use. That's a common practice down here in the shrimp farms, in the shrimp hatcheries, I'm sorry. Okay, that's it. Thank you for your attention. We'll thank Maria Lourdes Cobo for helping me in this presentation.